All right, so we're headed to chapter 5. Before I head there, do you guys have any questions about the test on Tuesday?
It's just chapter 4.
Only chapter 4, sections 4.1 through 4.4.
Outlets.
What's that?
Outlets.
Ah, yes. And make sure that you're, maybe try your laptop in this room since we haven't been in here. Try your laptop in this room and make sure you can get on the Wi-Fi just fine. As I look pointedly at Dylan. All right, chapter 5. Okay. Even though Ms. Parker told you to make sure. All right, so you should have watched the video for 5.1. Okay, this should have been done because that was due today. All right, so all of this should already be filled out on your notes. All right, we good? Because that's what I asked for. Okay. For the reciprocal square function, is this the embedded question, what I have hidden there? Okay. Is there something else that, it starts with number 2 for some reason. Oh, well. Okay. So what's the domain of the reciprocal square function? Uh-huh.
Union 0 to infinity.
And what kind of symbols do you have on your zeros? Round or square? Round. You're correct. Okay. Were you going to ask something, Dylan?
No, when you said symbols, I got confused. You meant parentheses.
Gotcha. Yeah. All right. So good job, November. What else? Somebody else give me the range. And what do you got on the 0? Good. Because I don't have anything down below. That's different than this one. Okay. All right. Increasing, decreasing, and constant. So let's remember these are always intervals and they're always x values. Okay. We've had these on every test so far. Hint, hint, nudge, nudge. Okay. So moving left to right. What is my graph doing first? It's increasing from where to where? Negative infinity to 0. Okay. And then what is my graph doing? From? Very good. Remember too that with increasing, decreasing, and constant, you never use square brackets. Remember that? Okay. Horizontal and vertical asymptotes there, x equals 0 and y equals 0. Here's just a little cute graphic that talks about a vertical asymptote is something you cannot get through it. Okay, you cannot touch that. So, yeah, I found that on Pinterest and I thought, ooh, that's cute. All right, so let's go to example number 1. This is interesting because in chapter 2, we had 6 parents. You remember the 6 parents that we started out the semester with. And so today is the first time we get a new parent, right? 2 new parents, actually. We've got our reciprocal function and we have our reciprocal square function. So 2 new parents. But we're going to do all the same things that we did to the old parents to these new parents. So things like reflecting over an axis, or vertical shift, or horizontal shift, vertical stretch, horizontal stretch, compress, etc., etc., etc. All that stuff we did in chapter 2 to the old parents, we're going to keep on messing with the new parents because that's what kids do. Okay? So when you take a look at example number 1, what is it about example number 1 that we just really don't like? Say it again. Okay, so essentially what you're saying, Blake, is I don't like fractions, right? Okay, you're right. That wasn't what I was looking for, but that doesn't surprise me because no student likes fractions. It's so very sad because fractions are our friends. But actually, Blake, I'm okay with a fraction because both of my parents are fractions. So I'm all right with that. But what's not like my parent? That 3. And the negative as well. But what am I supposed to do with that 3? Because you can't just magically turn a 1 into a 3. Okay, so what we're gonna do first is we're gonna take our function and we're gonna rewrite it so that it actually looks like our parent, okay, so that we know what to do with it. This is the same thing as -3 times 1 over x. Hey, that 3, if you made it into a fraction, what would it look like? 3 over 1. And if you multiplied the tops and you multiplied the bottoms, would you get the original question?
Yep.
Yeah. Yeah, because 3 times 1 is 3, 1 times x is x with a negative, right? So it's the same thing. I haven't changed the equation. All I've done is make it look more like the parent. And now that it's written like this, a description isn't so difficult. So think back with me to chapter 2. Oh man, I know that was a long time ago. Think back with me to chapter 2. How am I messing with the parent? Okay, what kind of a stretch? All right, so a vertical stretch by 3. Okay, that's one thing that's happening. What else is happening? Somebody else. So what do you mean by opposite? How did we word that in chapter 2?
Reflecting over the x.
Nice, nice. All right, so we're going to reflect over the x-axis. Now, domain and range, I'm not even going to mess with that until I actually have a sketch. Okay, and I'm not going to use the calculator for this. We can use the concept of parents. Which parent am I messing with? Am I messing with the reciprocal parent or the reciprocal square parent? The reciprocal parent. Do you remember back in chapter 2, I made you memorize the graph, which included like the special points on the graph? What were some of the special points on the reciprocal parent graph? 1, 1 was one of them, very good, and there was one more. -1, -1. Let's go back real quick. Let me point that out to you because I actually graphed several, but they're in green. The 1, 1 is a special point, and the -1, -1 is a special point. Okay. All right. By the way, we could voice that as right 1, up 1, and left 1, down 1. Okay. Be thinking in that way. All right. So now let's go mess with the parents. So, all right. So let's think about our vertical asymptote. Okay, now think about how we're doing this. We're gonna take our graph, we're gonna take our vertical asymptote, and we're going to reflect it over the x-axis. Ready?
Color.
Does it change? No, it looks exactly the same, right? So my vertical asymptote stays put. Let's go draw that on the graph. Okay. Now let's take our horizontal asymptote. Remember, we're reflecting it over the x-axis. It stays the same. Okay, so that's going to be exactly the same. My 2 asymptotes didn't change. All right, next. Let's take our special coordinate 1, 1, the right one and the up one. Okay. When I reflect that over the x-axis, in which quadrants is it gonna land? Yeah, down on the bottom, that's quadrant 4. Do you guys remember your quadrant names? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so it's in this quadrant, it's gonna flip down to this quadrant. Okay, so instead of right 1, up 1, right 1, down 1, except for the vertical stretch part. Okay, so now let's talk about the vertical stretch part. If it's going to go parent goes right 1, up 1. Remember, I'm not messing with the horizontal part, so I'm still going to move right 1. It's the vertical part I'm messing with. So instead of going up 1, we're going to go down, how far? 3. Yeah, because it's times that 3. Okay, so where I normally would have gone up 1, I'm going to go down 1 times 3, which is down 3. All right, so here's 1, 2, 3, here's -3. All right, the guy that was left 1 down 1, showing it on the screen there. The guy that was left 1 down 1. Where is he gonna land once he reflects? It's gonna be up here, right? And it's still gonna be the left 1, but we're not gonna go up 1, we're gonna go up 3. Okay, and now all I have to do is draw my curves. All right, remember that the asymptotes are like fences. It's something I'm getting closer and closer and closer to, but I'm never gonna touch it.
So like, for that though, do we have to find the other points?
This is all you have to find. And just give the generic curve. Well, now that I have a graph, domain and range is pretty simple. So what's my domain? Negative infinity to 0. Uh-huh. Very, very good. Where I'm skipping over my vertical asymptote. Okay, somebody else? What about the range? Let's start at the bottom. Now, I just put in the rounds. Why am I putting in the rounds, Blake? Yeah, you can't touch those asymptotes. You can't touch that. Okay. All right. Let's go to example 2. Now, when you look at the whole thing, what's the piece, the one piece that bothers you? Which 2? There's more than 1 2. Both of them? Well, the bottom one, I kind of know what to do when you add a number on the inside. I know what to do from chapter 2, I know what to do. So that one doesn't bother me as much. What's the one that does bother me? Yeah, the 2 on top, because what's it supposed to be on top? Yeah, the parent has a 1. So let's rewrite this first of all to be a 2 times 1 over x plus 2 minus your 1. And the minute you do that, can you guys see that I didn't change anything? That it's the same equation. I just rewrote it so that it's a little easier to see what my parent is. Okay, what I want you guys to do is come up with a description using each other. Okay, so talk to each other. Come up with a description.
So when the bottom is plus 2, so we're going to go to the left by 2 horizontally. So we go down on the y. So vertical stretch by 2, and then left 2, down 1.
All right, once you come to an agreement in your own group, spread your group out and ask another group, or people who haven't checked with each other yet. Like, what is it that you do so much on your phone during class? Because you are on your phone the entire class period. Are you texting? Are you watching a movie? What are you doing on your phone? You don't know? How do you not know what you're doing on your phone? Oh, Snapchat. Oh, man. Well, I should have known. Did you check with anybody, Mary Alice?
I think
Dylan and Whit-
sorry.
That's all right.
You are changing the horizontal and at least I think so. This will be perfect.
All right, let's find out, okay? So in our description, how are we messing with the parents? Name something. Left 2. And what tells you that you're moving left 2? Okay, so remember that anytime you add or subtract on the inside, that's going to go right and left backwards from what we think. Okay, all right, so somebody else. What else is our graph doing? What kind of a stretch? Vertical stretch by 2. Okay, and then Blake, what was it you said? Down 1.
Is it a vertical stretch by 2 because it's a positive 2 on the outside? Is that how you can?
No, it's a, what else would it be? A positive or a negative is going to be a reflection. It has nothing to do with the stretch. What exactly are you asking?
So how can you tell if it's a vertical stretch or not? He says vertical stretch by 2. So
Vertical stretch as opposed to a vertical compress? Okay, vertical compression, you guys tell me. How would I know if it was a vertical compress? Yeah, if my number is between 0 and 1, this number is between 0 and 1. So like a 1/2, a 3/4, a 2/3, a 0.1, a 0.9. All of those would cause a vertical compress. Okay, but it's not the plus or the minus. That is a reflection. Okay, so that doesn't have anything to do with the vertical stretch. All right, so now let's go to our asymptotes. Vertical asymptote. Okay, so the first thing that we're going to do with our vertical asymptote, let's stretch it by 2. You ready? Stretch. How does it look? Looks the same, okay? And then we're going to shift it down 1. You ready? How does it look? Same. And then we're going to shift it to the left 2. How does that look? Does that look? Sorry, I have to go backwards from you guys, so it's going to go to the left 2. Okay, so then let's take our vertical asymptote and let's shift it. That's to the right. Let's shift it to the left 2. Okay, horizontal asymptote. Ready? Stretch it from the top and bottom. How does it look? Same. Okay, my asymptote doesn't get thicker. Okay. Move it to the left 2. Same. Move it down 1. Does that change? Yeah, it does. So let's shift it down 1. Where were the special points? Remember, it was right 1, up 1, and left 1, down 1. Okay, that's where the special points were. Now, you ready for this? This is actually kind of nice. Where my 2 asymptotes cross each other, treat this as your new origin. Treat this as your new 0, 0. Now, if I had no stretches, you looking up here? If I had no stretches, I would just go right 1, up 1, left 1, down 1, and I could graph. But I have a stretch, okay? So we're gonna go right 1 because I'm not changing anything horizontally. And when I stretch it, I'm gonna go right 1, up 2. This is from that new origin. So right 1, up 2 lands me here. Go back to the origin. And from the origin, you're going to go left 1, down 2. And then just draw your curves. Stay inside the fences. Now be careful when you come up with your domain and range. Okay, so what about domain? I'm gonna write these down here because I used up my space.
Do we still treat the new origin as the new origin? So would it be negative infinity to -2 then?
Very good. Yep, because that breaking point is at the x value -2. Okay, because my graph goes all the way up to this point. This is x equals -2. Okay? Round parentheses on there. Where do I pick up again? -2 to positive infinity. Good job, November. What about my range? Negative infinity up to -1, because -1 is where I'm taking that break in my y values. Okay, so this is where I'm taking the break in my y values, and that's at y equals -1. And then continue. -1 to positive infinity. Does that make sense? There was only one that we didn't do, and honestly, that one's not that bad. If you'll remind me when we get back from fall break, we can work that one. But that one's gonna look so much like the other ones that I don't feel, if you get the other two, I don't think you'll have a problem with this one. Okay, the only difference is I'm changing the parent. So domain and range makes sense, Becca?
Yeah, it's a little bit takes a little more brain work.
It does, it sure does. Because you're not just slapping down something that you did every single time. All right, guys, have a good weekend. I'll see you.